Arithmetic sequence is a very simple type of sequences that have the following recursive connection. an plus 1 equals an plus d. So what is this connection? It says that every time when we build a new member, we add a fixed amount. That d is called d is difference of the arithmetic sequence. So this sequence generally depends on two parameters. So if I have two parameters, if we have first member and the difference, then we can answer two most important questions. Question 1, how much is an? And question 2, how much is Sn, which is a1 plus a2 plus an. So question is, how much is an? So, one of the ways how you get the formula from recursive sequence is just play with the first few members and it will give you the idea what it should be. So a1 is a1. How much is a2? a1 plus d. How much is a3? Is a2 plus d, but that's a1 plus d plus d, so altogether it's a1 plus what? 2d. What about a4? a1 plus an extra d, it will be 3d, so it's very easy to guess the formula. What would formula be? a1 plus n minus 1d, because from a1 you do n minus 1 steps. And that's the formula. But I don't like, there's something that I don't like about it. What is it? I kind of did a few examples and it gave me a hint what it should be. If I want to trust this formula, what should I do? Prove by induction. So proof by induction. Am I going to do it on the board? No, but you will do it as exercise. It's fairly easy, just n equals 1, then k plus 1. It's very, very easy. All right. What about Sn formula? Formula for the first n members actually uses the following fact, that that's a famous idea of Gauss, just a little bit extended. The idea is the following one. If you look at A1, that's just A1. A2 is A1 plus D. A3 is A1 plus 2D. An minus 1 is what? A1 plus n minus 2Ds. And An is A1 plus n minus 1Ds. Do you agree with my writing of all the formulas? Then what happens? If you look at the first and the last member, what is their sum? 2A1. So A1 plus AN, I better write it inside. A1 plus AN is 2A1 plus n minus 1D. What about A2 plus AN minus 1? So here I go down and here I go up by 1. What happens? By going down here by 1, I gain a D, but by going up, I lose a D. So what happens? The sum is the same. And then A3 plus AN minus 2, and so on. So the only problem is that if it's even number, I'll have pairs, do you agree? What if it's odd number? The number in the middle doesn't have a pair, but I can say it's a pair with itself. Do you agree? So what happens? So generally, the question is, how many pairs do I have here? N over 2. And if n is even, I'll get whole number of pairs. If n is odd, I'll just get half a pair for that individual, which is absolutely fine with calculation. So what's the formula then? So Sn is what? How many pairs? N half pairs. And then which pair do I take? I'll take first and the last, and here it is. So n half times a1 plus an, or if you want me to do this in a more detail, what would that be? N half a1 plus a1 plus n minus 1d. And then if you want to take that half, then it will be like this. A1 plus a1 is 2, a1 over 2 is a1. So it says a1n plus n times n minus 1 over 2d. Everybody remembers it in this form, but if you want just a1 and d as your only parameters, here is the way to do it. So generally your shift is repeated n times, and then this is the sum of those. By the way, this is n choose 2. So this is the story about arithmetic sequence, and then there are many problems that are fairly simple to solve. Sometimes they also show up on the Arithmetic, and they ask you, they give you two other things, and you need to recover the problem. Those are really absolutely simple. So let's see a couple of problems quickly. Let me do something from your homework then. All right, for example, problem number 4 says the following. A3 is 7 and A10 is 28. Can we recover this arithmetic sequence? What is this basically? If you want to write those two equations and write a system, then you will get two equations with two variables. So what is this? This is a1 plus 2d, and this is a1 plus what? 9d's. And then you have system of two equations with two variables. What's the easiest way to solve it? Subtract them. So you get 21 equals 7d. So d is what? 3. And then once I have d, then I say what? 7 equals a1 plus 6. So a1 is 1. So here is our system. So a1 is 1, and d is 3. And that's it. Of course, can you do this much simpler without any formulas or anything? What? From level 3 to level 10, how many steps did I do? 7 steps. 7 steps are worth 21, and they are equal steps, so each of them is worth 3. Then what? Go 2 back to A1, so that's 1. So you don't need any equations or anything. It's really just common sense. All right. Yes?
And this is S sub 20. Isn't that the sum? 1 plus S, A sub n plus A?
Yes, it does. Oh, for this sequence, calculate S20. Sorry, I didn't answer the question. I recovered the sequence. Now they want S20. So how do I get S20? Here it is. A1 is 1. How much is A20? 1 plus 19 steps of 3, so that's 57, and 1 is 58. Do you agree with me? I just used the formula. It says if I want 20 steps, I'll start with 1 and take 19, which is n minus 1 steps of 3. So that's 58. So how much is S20? 20 over 2 times A1 plus A20. So that would be 10 times 59. And the result, or 590. So, you know, for arithmetic sequence and the same for geometric that I'll just introduce in a minute, once you know A1 and D, they can ask you whatever they want. You know, then everything is just simple for a couple of formulas on the left, plug it in. And then what? What geometric sequence? Most of you already took calculus 2, so you know that you studied geometric series. And geometric series is actually infinite one, and they had told you how to do infinite summation, but probably they never told you, or they told you very quickly how to do the finite summation of geometric sequence. So here it is. Here is the question. So suppose, so this was the quick story about arithmetic sequence. You know, it's not really level for this. Very often we teach this in pre-calculus even, but I thought it's a good idea to make it sure that everybody has this specified. Here is the question. How much is 3 plus 6, no, I don't want 6, no, I want 2/3 plus 2 plus 4/3 plus 8/9 plus 16/27. I'll ask you this question, and I'll also ask you the following question. Do it forever. So keep doing it forever. Add all those little pieces until infinity. How would you answer these two questions? So on top, I just want first 5 members. On the bottom, I want infinitely many of them. Do we have an answer?
Finite sequence. First one, just add them up.
What say?
Top one, you can just add them up.
Yes, but what if I add a few more, if I add 20 of them? So can you have a quick counting? That's one of the main themes of this course, quick counting when things get bulky. So what's special about this sequence? Actually, if you look at the members, I'll call them B's now, not A's, just to contrast from before. If this is B1, B2, so I'm adding them up. Okay, I'm doing sum, but generally I want to identify the members first. What can you see? So sequence versus sum. So B1 is 3, B2 is 2, B3 is 4/3, B4 is 8/9, B5 is 16/27, and so on. Yes.
Are they all multiplied by 2/3?
Exactly. So every time from all the members to get a new member, I multiply by 2/3. Do you see that? I get an extra 2 on top, extra 3 on the bottom. Actually, what's fixed here is that I get an plus 1 equals an, but times r and not plus d. So the same as arithmetic, but it's times. Although, can this become this? If you take log, geometric becomes arithmetic under log sequence. Doesn't matter. So in this case, here is the story that here is the recursive connection. And then, if this is the recursive connection, I'm asking, so what I ask you here is S5. So what is S5? First 5 members added up. Sorry, B's. Let's call them B's, not A's. Not essential, but just psychologically, if it's B's, we know we are talking geometric. So S5 is B1 plus B2 plus B5. And this one is S infinity, which is B1 plus B2 plus B5 plus forever. And then what? Funny enough, you studied this, but maybe you didn't study the upper one. So you studied this bottom one in calculus 2. Why? Because you call this in calculus 2 geometric series. And this is just finite sum, and as I said, you skipped it because you were in a hurry to do infinite sums. So, what should we do here? Let's do the same actually methodology as before. So, I'm sorry, let me call questions Q2 and Q3. So question Q1 is, can I have a formula for Bn, individual members, no sums? So, can I ask the question, how much is Bn? What is it? It's B1, but instead of plus D, plus D, plus D, which is plus ND, I'm doing times R, times R, times R, which would be what? R to the what? Minus 1. Here is here. So instead of adding n minus 1 times, I'm multiplying, so that gives me the power. Do you agree with this? So now, if I want, for example, B5, what is B5? Well, let me see if I really get B5. What is B5? It's B1 times 2/3, because that's your ratio, to the 4th. So that would be what? 3 times 2 to the 4th, 3 to the 4th, which is 16 over 3 cubed, which is 27. So really gives you that quickly. So this is an explicit formula where you don't go step by step, but you calculate. Okay? Now we want question 2. How do you add up geometric sequence? You call it then geometric series. So how do I add a finite geometric sequence? So what would that be? Sn equals B1 plus B2 plus B3 plus Bn. That's what I want. Sum of the first n members. So what do we do? There is a very nice, easy trick. It's very elegant. And here's the trick. I will multiply it by r, both sides. I can write it as powers, but it's even nicer if I write it like this. So what do I get? I get Sn times r equals what? B1r plus B2r plus B3r plus Bnr. Do you agree with my algebra? But here is the crucial thing. How much is B1r? Recursive connection. How much is, when you multiply by r, you go one level up. So B1r is actually what? B2. How much is B2r? B3r is B4, and so on. Here is Bn minus 1r, which is Bn, and this guy is just what? Bn plus 1. And what do I do? Now I will subtract these two lines. And what I'll get when I subtract? We'll get the following. Snr minus Sn equals. This is B2 and B2 cancel. B3, you always cancel up to the right. So this guy will cancel this guy. So who's the only one left? B1 on a minus and Bn plus. So it's Bn plus 1 minus B1. And that's the summation formula that we had before. So what would that be? I'll factor out Sn. Here is r minus 1 equals Bn plus 1, which is B1 r to the n minus B1. Because Bn plus 1, I call this formula B1 r to the n. And then what? If I just divide, here's that famous summation formula. We already had it before to show induction or something like that. It's a B1 r to the n minus 1 over r minus 1. This is the summation formula because I factor out B1 r to the n minus 1 on top, r minus 1 divided. Here is that summation formula. So that's summation formula for n members of geometric series. So now I can answer question 2, but I have to erase something. Let me erase these guys. I don't need this anymore. So what is it? What I have there is S5. So formula says S5 equals, what is it? It says B1 times r to the 5th minus 1 over r minus 1. So who's my B1 in that sequence on top? Who is it? 3 times. My r is 2/3. 2/3 to the 5th minus 1 over 2/3 minus 1. And that's the final result. By the way, look at my fraction. Are both numbers positive or both numbers negative? Negative. When that's the case, when your r is less than 1, we usually flip them. So what do I get? 3, we more like this, makes more sense and avoids negatives. So what would that be? 1 minus 2/3 is what? 1/3. On top, I get what? 1 minus 32 over 243. I don't know if you need this, but let's do it. So this would be times 3, so it would be 9 times 243 on the bottom and 211 on top. And then 9 and 243 cancel, so I get 27, so 211 over 27. Of course, common denominator is 27. So here's the way to do it. Now what? Before we take a break, let's answer the question 3. So this was question 2, summation for a geometric series. What about question 3? S infinity. So how do I get S infinity? This formula, S infinity what? Can we add infinitely many numbers? No, we cannot. We can only add finitely many numbers. And how do we add finitely many numbers? Recursively. That's the only way how you can. How do we add the 20 numbers? 2 at a time, do you agree? So that's recursive. Add first 2 when you are done, add the third one. When you are done, add the fourth one. So even finite addition is actually a recursive operation.
You couldn't do it with summation?
Usually there's no summation formula. There's only summation of 2 numbers. If you remember when we studied in chapter 1, when we did those digital circuits and something like that, you study how to add 2 numbers. And if you have 20, you don't feed all 20. Actually, the way program works is what? Feed 2. When you are done, bring third one, bring fourth one, bring the last one. Yes?
So it's not really a summation formula because we're not adding all of the terms up until then. We're just adding
2 at a time. Exactly. So when you add this, unless you have a formula, but 23, then what do? You do the following. 1 plus 2. When you get the result, then you say, put 3 on first, bring the bottom this one. When you are done, bring next one, and you always bring 1 at a time. So generally, it's exactly a recursive operation. But anyway, infinitely many, you cannot live long enough to do recursion infinitely many times. So what do you do then? S infinity that you get in calculus 2 is not recursion at all. What is it? It's a limit. That's a key thing. So that's why that's calculus. This is discrete mathematics. I can add 20 numbers. I can never add infinitely many. What is this? S infinity is limit Sn when n goes to infinity. Do you agree? And that's what they gave you, but probably didn't follow that summation formula at that time, maybe not even today. So it's what this? Limit when n goes to infinity, and I call summation formula B1 r to the n minus 1 over r minus 1. And then what? Now I can repeat that proof from calculus 2. What happens? If absolute value of r is greater than or equal 1, what will happen? This is constant. There are no n's here. The only sensitive part is this one here. So what? If your base is greater or equal 1, it diverges. What if your base is by absolute value less than 1? then this goes to 0 and disappears, and here's your limit that they taught you. So what is the limit? Negative 1 over r minus 1. And then when you flip them, S infinity is what? B1 times 1 over what? 1 minus r. And that's the formula. They just gave you the formula. You memorize it. But then the formula comes of the finite summation when you take a limit. So in our case, what would that be? So our S infinity, how much is my first member? 3 times 1 over 1 minus 2/3, and that's 9. So if you add all these little numbers forever, sum will get bigger and bigger and slowly approach number 9. So that's that infinite sum. So that infinite summation formula is combination of the finite summation formula and limit when it goes to infinity. So that was geometrics. The question is, why didn't I ask the same question for arithmetic sequence? Why didn't I ask for infinite sum on arithmetic sequence? Always diverges because members never approach 0, because you have that n, and then, so if you look at the members, nd, a1 plus nd, limit of this is always infinity, because unless d is 0, and a1 is 0, because then, so, no, a1 doesn't have to be 0. We are not adding them up. So limit of the member like this is infinity, so members are not approaching 0, so it doesn't make sense even to ask that question. 3 for arithmetic sequence. All right, let's take a break. We'll continue at 37, 38.